in history, but they fight over place in it. Yeah, they fight over place in it. Honey, by the times, they just have the love goes by. I know it's not your fault to say, but there ain't no other way. So step on up to the plate. Need your faith, we can spread out into the light of love. Step on up to the plate, 'cause this ain't a game. It's time to make history, yeah.
Hi, everybody. Welcome to Wednesday's lecture, quote-unquote, edition of Chem 140. The purpose of these Wednesday lectures isn't to lecture about new content to you, because that's Monday and Tuesday. We do that for 4 hours a week, and that's probably enough material for you to digest, and you don't really need that much more piled on top of your plate. So the purpose of these is going to be used for review, where I answer any questions that you might have. You just post them in the chat, and I would encourage you to do that now if you had them. Just type them in the chat, and I will get to them eventually. But before we do that, I want to talk about the lab part of this class, because the lab discussions end up being very, very short, like at most 20 to 30 minutes. This one probably will take 20-ish minutes, and most of that will just be like, this is how labs work, and not talking about the lab itself. Oh, someone else wants to say hi. Say hi. There you go. I'm busy. Say hi. I can't get the mic in your face. Say hi. There you go. Okay. Maya says hi. Most of these experiments, I have to do that when Maya comes by, or else she won't stop bugging me. Most of these lab experiments involve a worksheet that you will download from Canvas. I have Canvas on the screen here. And I do realize that part of this is covering chat. It's just that if I could do this, but then you can't see what's on the right side. You don't really need to see it right now, so that's okay. But if I do this, like, nobody can read anything. So I'm just trying to make this as big as possible. Yeah, we can definitely go over that worksheet problem, but we'll do that once I get more questions. So just keep adding those questions into the chat. I'm going to do the lab part first. So if you have done the orientation quiz and gotten at least 100%, so a perfect score on it, which I believe at this point nearly everybody has, then all of these other files appear, including the lab documentation. Now, this right here, how to upload your worksheets in Canvas, I'm going to basically go over that today, just showing you the process live, because some people like to see something that they can reproduce on their computer at home, so I'm going to do it that way. I'm also going to click on each of these files and show you where these links go. So if I click on this, where it ends up is this page right here. And my recommendation to you is, provided you have a PDF viewer at home, if you don't, you can get Adobe Acrobat Reader for free. Click right here where it says Download Lab Worksheet number 1. You'll get a copy of it for yourself, so you don't have to be on Canvas to access this. Now, the lab worksheet has a bunch of different sections that either require you to read something or require you to answer questions, okay? Generally speaking, the sections that have questions in it will literally say questions or say something about the experiment in its nature. For example, I have pre-experiment questions. These are designed for you to answer after reading the documentation, but before watching the video. There is a video right here that's linked in here. In the experimental section, I'm going to show you what you would do if you were in the lab. Like, normally we would have you do this experiment. We would give you all the chemicals, we'd give you all the equipment, we'd pair you with a lab partner of your choosing, and say, good luck, we're all counting on you. Well, I say that, everybody else doesn't, but I'm trying to get them to say it. Since COVID is a thing and all of our courses are online, and shipping you chemicals to do this at home is probably not an ethical or morally responsible thing to do, I went into the lab and did the experiment for you. And I recorded it, and I put goofy music, and I put not subtitles, because I don't talk in the video, I just do the experiment. And I'm going to show you parts of that video in just a little bit, but I'm going to go over the gist of, like, the technical details before I talk about the experiment at large, okay? Down here are some questions that you'll want to answer, and so on. Now, there are a bunch of questions, obviously, that need your input, but you can't type in anything into this document. So, if you go to where it says Google Sheet for lab number 1 and click on that, you'll get this window. And then my advice to you is to click up here where it says Google Sheet for lab worksheet number 1. This is just a link that will take you to its own page. And that looks like this. All right, so this is the lab worksheet. Now, I can type in whatever I want to. I can do anything I want to, like hello, or stuff like that. But what you're going to notice is that as you try and type into this, nothing happens. It'll say, you need permission. What you do not do is ask me for permission. Okay? If you send me an email that says, hey, so-and-so wants permission to edit your document, I will delete the email. Okay? Instead, here is what you do. You don't need my permission to access this file. You have to do the following. Go up to here. So here's my cursor. We're going to go up to where it says File. And I'm going to go down to download, or not download, I'm sorry, make a copy. So you're going to make a personal copy, and you can name it whatever you want to. Do not check share with the same people, because nobody else needs access to it other than you. And do not check copy comments, because there are no comments. So hit OK, and a new window will open up, and this is your personal copy. And then you can enter whatever you want into the document. It is now your copy that you are free to modify how you see fit. I have given permission for you to copy it and write all over it. But you cannot edit the master copy, because that's what everybody else is downloading. Otherwise, you type something in there and somebody else would download it, and then they would have to delete all of your comments if they were wrong or whatever. Okay? So now you have your copy of the document. In the document, anything that is painted blue, so you can see all these blue spaces here, require your input. If you type in any other box, I don't grade it, because I can't possibly find it, right? So I only grade what's in blue. So if you want to make your own notes somewhere down here, or maybe like calculations or whatever, totally fine. You can do that, but I won't grade it. If you refer to it in an answer, I will look at it, but you have to point me at it, okay? So if you say in your answer, I did a calculation in cell B29, and I got to the answer 14 joules per mole. I don't know. If you show me that or link it like that, that's fine. I can deal with that. But if you just have stuff floating around in the ether out there, I will never find it, because I have hundreds of these to grade. So just keep that in mind. Please only put your answers that you want me to grade in the blue spaces if possible. But if you need to, you can refer to an external cell as fine. That was the next thing I was going to answer, actually. So in the name spot, obviously type your name. I'm doing this very literal, so obviously type your name if you were turning this in. Now, in the section box, when I first did this, the only designations we had were OL, and then we had A, B, C, D, E, F, G, whatever. So that's your section, is the letter. That comes after that. We now have the LS designation, which is what this class is, because I give a live stream. Online is you watch a recording, and then I'm available, and we just do office hours for lecture time. But LS is I give a lecture at a normal time, and you're expected to be there at that time, although I sort of do a hybrid of those two, where I put it on YouTube. You watch it whenever you want to. I don't care if you attend or not, because I don't know what your schedule is. So the LS designation is what our class is, and then you need to enter in either D or E, which section we are. So if you are in 2536, that is section D, and if you are in 2537, I believe that's E. Now, alternatively, you could put in those numbers, 2536 or 2537. You get that information from your unofficial schedule, I believe it's called. It's in your My EVCC, and there should be a button that tells you, like, this is my schedule, and it will say the course number and the letter code. You can enter either of those in there. So either enter LSD or /LSE, whichever one you're in, or 2536/2537. If you put one of those, I will recognize it. If you leave it blank, and I have to sort you into the correct class, I might misplace your lab, and there might be delays in grading it. So this is just an administrative thing that I ask my students to do. Most of the time, it doesn't really matter because I think Canvas currently will sort you into the correct section anyway. So if you leave it blank, that's also okay. But I would prefer that you put something in there in the event that I don't know where you should go. All right. Anything in gray on the left here? I realize some of it's cut off on the screen, but that's okay. Anything on the side here, these are formulas that I have written to help grade. So if I were to give this response 3 points, you'll notice that all the numbers change up here. If I were to like, oh, -50, ooh, that's not good. Like I can type in whatever I want to, because I've written a formula to make all of this grade easily. So I can just go through your answers and go 1, 1, 1, 1, 1. Please do not write in the gray column. If you do, I will 0 your score. Okay? Do not write in that column for any reason. You will not receive a grade for the assignment if you break all my formulas. Okay? Because, again, I have hundreds of these to grade. And if you make it take longer than it needs to be because you are being careless, I will just move on to the next one and not score it. Okay? So, very, very crucial. Do not touch the left column. Down at the bottom, you could see it. It's down here. So down at the bottom, you'll see these tabs here. These are different tabs that correspond to different parts of the worksheet. So the first section, pre-experiment questions, asks you 3 questions, and you'll see that those are these 3 questions here. Notice that I haven't reproduced everything, and that's because I can't quite fit it in here and not take up a ton of like dead space. So that's what the documentation is for. So that's the wrong page. Sorry, here we go. So question number 1 in this asks you to look at this chart where I mixed A with reagent 1, A with reagent 2, A with reagent 3, and so on. And I filled in the details. And then I'm going to ask you questions about that. When you mix C with 4, what do you get? Describe it in the worksheet. So you'd say, when reagent 4 is mixed with substance C, everything explodes and I am sad. I almost wrote dad. I don't know why. But obviously that's not the correct answer, but you would do something like that. Try to write incomplete sentences if you can. It helps me understand what you were trying to do. If you just wrote orange, then I may not know the context of your question, even though it is written above there. Again, I am trying to do these really quickly and accurately. So complete sentences is good. More information is better. Obviously, don't write a novel. If you exceed the space filled in by these boxes, your answer is too long. Okay? So I've given you plenty of space. In fact, for this box, you won't even need to write more than a sentence. But some of these will actually require like maybe a paragraph for you to answer. And please answer them completely, but don't answer so much that you go off of the screen, because if it doesn't fit in the box, then I have to make the font smaller, or do other things to it. And generally, me modifying your lab is not a good reflection on your work. So, all right. Once you've answered these questions, the next set of questions can be accessed by clicking the tab at the bottom that's next in the sequence. So after pre-experiment, you have the experimental questions. The experimental section for this particular lab is a giant chart. Note that it does scroll down and that it does scroll slightly to the right. So make sure you don't miss that column on the right there for sodium iodide. Make sure you're following all the directions. I have split these boxes into 4 lines for a purpose. It tells you what to do right here. It also tells you what to do in the lab. I've printed it in both places because I don't know who reads what. Again, I would recommend reading the lab documentation first before going to the worksheet, but you do you. And then finally, there is a third tab down here that has some other questions and then asks you to do something. Okay? Note that you do not need to write your name on every page because it autofills from the first page. So whatever you type in here will appear on the next page because, again, I have written a formula. Don't overtype that, especially if you overtype it with something wrong. Just be mindful of that, okay? All right, if you do overtype it, like that one in particular is okay because I don't care, but especially be wary of the gray column. Don't type in it. I know it starts your cursor up here. Don't start typing over this because that would be bad. All right, that's the gist of how these work. And when you are done with your questions, you're going to need to give this file to me somehow. Again, do not share access with me so that I can access this file because I can't do that for 100 labs. Like, that would just take forever. Instead, what you're going to do is you're going to download it and submit it to Canvas because Canvas will collate them all together for me and send me one zip file. Here's how you get your copy of the worksheet. You go up to File, and you click Download, and you're going to choose Microsoft Excel.xlsx. If you choose any other option, I will not be able to open your file, and you won't get a score, okay? So you have to do it this way. You click on this. You can't see this on the screen, but it just asks me, select where you'd like to save the file. I just save it to the desktop. So I have done that. You can see it down there at the bottom. It has appeared. Now we're going to go to Canvas. And I'm going to go to Assignments. And you'll notice that all of these are gray, which means you can't see them. But after today, I'm going to go like this, boop, and you'll be able to see it. This is my personal blueprint, so that didn't do anything for you. But once it's available, this will be shown. And when you click on this screen, it looks different for me. Let me go into the student view here. I can't do that unless I am... students don't have access to a blueprint. I forgot about that. So I got to actually go into a course. All right. I'm going to temporarily open it because I need to actually go in and do that. But when you go into the student view, this is what it should look like. Why do I have to log in? I'm a student. Oh, goodness. Okay. So you're going to see something that looks like this. This is stupid. This is a bug. Let me reset the test student. There we go. That's what it's supposed to look like. All right. You'll notice that it will only allow XLSX files. All you do is you take your file and you just drag it there. Or you can click on Files and upload the file that way. Don't use any of these other options. Like, obviously, I don't want to see a webcam. Google Apps or assignments. I do not want a direct link. I need the file itself. Once you have uploaded it here, you just go down here to where it says Submit Assignment that you can't see because it's off the side of the screen. Hold on. Oops. There it is right there. You go to Submit Assignment, and you're all set, okay? Once you have submitted your assignment, you are allowed to edit it. If you find out later that, like, oh, there's a mistake on my worksheet, can I go back and edit it? Absolutely. As long as it is before the deadline, just go back to the lab worksheet and upload it again. When it asks you, do you want to overwrite the previous submission, say yes. If you don't, I think I get like 7 copies of it, which I will just grade the last one in the sequence. So obviously don't add mistakes to your paper. But yeah, when it is done, I will re-upload it, and it will be available here, because I download all these. And then I grade them, I open them in my Excel, and I paint them yellow if there are mistakes, and I write comments on them so that you have feedback. Okay? And that's it. That's the gist of lab assignment number 1. So let me leave the student view. All right. And then I'm going to close this because I actually have to set a deadline for it real quick. So anyone who submitted their assignment, it might not count if you did it now because it's unpublished now. So do that after I reopen it. Okay. That's the gist of how this works. So step 1, make a copy of the assignment Google Sheet for yourself. Step 2, download the lab PDF and use it to fill out the Google Sheet. Step 3, download your own copy as a download your own copy as a Microsoft Excel spreadsheet and then upload it to the Assignments tab in Canvas, okay? Very important. You have to do those 3 steps in that order. Do not use any other Excel-based spreadsheet to do the assignment. You will receive a 0 if I can't open it, okay? I've had in the past, I was using an ancient copy of Excel. I used it from grad school. It was like Microsoft Excel 2003. And the only way that I could grade students' reports was if they did it this way. If they used their own version of Excel, it was incompatible with mine. If they used the online version of Excel, it was incompatible with mine. You have to do it this way, okay? I now have a much more modern version of Excel because I was able to get an update when I was installing Windows 10 this summer. That said, I don't know how compatible Excel 2016 is going to be with other random stuff out there. I know it works with this, though, because I have tested it. So please follow this procedure that you've seen here or is documented in the how to upload lab worksheets to Canvas. If you do any other way, it is at your own peril. And if you turn in something I can't grade and I go to grade it, you get a 0. Okay? Don't take the risk. Do it my way. If you have any questions about how to turn in lab assignments, let me know. Now I'm going to talk about lab number 1 in a little bit more detail. So we no longer need this copy. I want to talk about this. So scrolling back up to the top, we'll put the cat and the rat on the screen. Lab number 1 is all about observations. Now, thankfully, in an online class, we have our eyes to make observations, but eyes are not the only sensory organ that we have to make observations in the laboratory or in the world around us. For instance, I can observe that there's not a cat in this room, and I'm very surprised about that. Now, I could do that with my eyes by looking around, but I could also hear the cat crinkling around on her paper bag because she loves the stupid paper bag from Fred Meyer. So if I hear that, I'm using my ears to make an observation that there is a cat detected. I could smell the cat, I guess. Maya doesn't smell like anything. She smells like a cat. I could touch the cat. I pet her often. In fact, oftentimes she bumps into me, and I'm like, oh, there's a cat. And I'm not even going to consider licking the cat because she licks me instead because cats do that. Maya loves to lick people's hands and fingers. I guess because I'm salty. I don't know. So those are the senses that we can use to observe stuff. Obviously, some of those are inappropriate for the lab. You would never taste anything in the lab. But you would certainly touch things. Like you could touch a container and be like, oh, it got warmer. That's a good observation. If you mix 2 things and you hear that it starts fizzing, or you hear the sounds of something burning, or you smell like a chemical odor, these are all good things to note down for observations. And we talked about observations in Unit 1. It's important to make observations of an experiment so that we could do the experiment again and reproduce it and match our observations and generate scientific laws and then eventually theories. Now, in the laboratory, objects are not as distinct as this kitten and this big fuzzy fat rat are. In fact, these are two substances that are white and crystalline, and if you could taste them, you could tell the difference. But obviously, you can't do that through your monitor. So we need other methods to distinguish chemicals. Is that how they discovered pH? Very likely. However, that may not be appropriate nowadays. In fact, there are many things that were done in the past that I would strongly recommend against. For example, if later on we're going to learn about the pipette. The pipette is a small glass tube that is used to collect liquid samples of very consistent volume. The original technique to do that was you suck the liquid up until it gets to the line, and lots of scientists would oversuck and get the substance in their mouth. Many of those substances were carcinogenic, and they later died. Or they were toxic, and they later died. Or they were mutagenic, and they could no longer have children without birth defects, and then later died. So, going by precedent may not be the best philosophy, okay? So in the lab, we're going to be extra safe. No tasting anything ever. Generally speaking, no touching things without gloves. And then using common sense when it comes to manipulating objects that may be excessively hot or cold. I'm saying this all as if we were actually going to the lab, but you get the point. You would have safety equipment. In fact, in the video, you'll see that I have safety equipment. When we're trying to distinguish these two things, we can't use our senses. We need to use chemistry. And so what I'm going to do is I'm going to mix things together to try and find distinct results. So on this chart down here, yeah, radium is like a prime example. We'll talk about radium in a little bit. Once I I'm mixing all these things together, and now I just said something that could be construed as inappropriate. Once I get to the end of this, I don't want to be off topic, sorry. Once I get to the end of this discussion, we'll talk about radium and radium paint and X-rays and other fun things. So the pre-experiment questions here ask you, yeah, don't touch the demon core. That's another good one. I've read all about that thing. These substances here are not substances that are in the experiment. I have just made these up. I've called them A, B, C, D, E. I've called them 1, 2, 3, 4, 5, and I made up some results. So when you mix A and 1, it turns milky yellow. When you mix A and 2, it turns red. When you mix A and 3, it's colorless and clear, and you can see through it. And so on and so forth. Now, the premise here is that if you do a bunch of different tests with two objects and those objects are the same material, you should get the same result, right? So object E is one of these four things, A, B, C, or D. What is it? I don't know. Look at the table and determine and describe how you came to your answer. I do ask you other questions, and I want you to make your best conclusions that you can based on the reading here in the introduction and later on in the experimental section when we get to those questions. In the experimental section, you're going to be filling out that giant chart that I had. My page might have fallen asleep here. There we go. You're going to be filling out this giant chart with the results of the experiment that I have recorded. So I'm going to go copy that video right now. Oops. And give me a second to capture it. There we go. We'll do that. Just because half of these are my lectures, apparently, in the recommended videos. So this is a video of me doing the experiment. There is cheesy music. I think I have the music muted for you guys. So I realize I'm overweight. That's fine. So I recorded these substances, and we're gonna react these three things. Wow, good timing on me pausing the video with my eyes closed. There we go. So you're gonna be working with three unknowns. The first unknown is a sodium blank solution. And you'll notice that my container just says sodium on there, and the label got torn off. The other one over here says just blank nitrate, and it got damaged. And then the third one just says unknown number 3, and that it's a nitrate. So using your observations, i.e. your eyes, you're going to look at these substances and try to make conclusions about them. And then what we're going to do is we're going to start mixing things together. These are labeled with things that I was able to read, so I wrote those names for you. And then when we start mixing stuff, I put little subtitles on the side of the screen there. There we go. Like so. Now you can tell that the camera is a little bit blurry. And this is kind of an unfortunate side effect of me having like a teeny tiny 3x4-inch screen to look at. Because I was doing this with a handheld camera on a tripod. Because that was what media services had available. It looked fine when I looked through it, but it's obviously a little bit blurry here. And when we mix the stuff together, so I'm just going to hit play here for this first one. So I'm going to mix some sodium hydroxide just as an example. And you can see me doing it slow, and then I fast forward because you don't want to watch that. And then what I do is I move this. Well, first we stir it. No, Professor West, you stir the solution. Fine. There we go. And then I do this. I bring it close to the camera, and you can tell that's real blurry, and I had no idea. So I apologize for that. My advice is to, one, obviously do the best you can, but two, use this piece of paper that I put in the background as a bit of a guide to tell you, did light pass through it? So you could see here, there's some light reflecting off the paper that lights up. You can also see that here, but you don't see it in this one, and you don't see it in this one. So if you see that sort of pattern, light is passing through it, so the solution is transparent. But if you don't, the light did not pass through it, and the solution would be opaque. And you can make some general observations based on that. So, number one, it looks like nothing actually happened. Number three, it doesn't look like anything happened there. But number two turned blue and chunky, and whatever chunks formed, they sort of settled towards the bottom. So you could see that. And then in number four, it looks a little darker, whatever. You can make whatever observations you want to, but you're going to write them in this table. So this was sodium hydroxide, and I mixed with solution 1, solution 2, etc. So in the first cell, record the color. So the first one was clear and colorless. Actually, I should say colorless, because clear is not a color. Clear is, can you see through it? In the second cell, is it opaque or is it transparent? So it looked transparent, so we would write that. And then I would record the texture. I would say that it has no texture or features because it was basically just liquid. Do not write liquid, though, because all of them are technically liquids, and liquid is not specific enough. And then finally, in the fourth block, I would write anything that reminded me what that looked like. So this first one looks kind of like water, but maybe a bit darker. I don't know. That was my impression of it when I saw it. It looks a little dark or something. So just something to write down that if you were to see this again later, you could look at that and say, oh, that's what that is. Okay? So your goal is to write down a description that is sufficient enough that if you see it again later, you'll recognize it. Because you're going to be looking at unknowns all mixed together, and you're going to have to rely on your giant chart here to figure out what's going on. Okay, so that's the video. I do this for 5 minutes. I mix a bunch of things together. And then at the very end, I mix all the unknowns together. Tube number 1 is sodium blank. and the other 2 tubes are blank nitrate. For the entire experiment, we were mixing 1 sodium at a time with all of the nitrates down the line. We're writing down the observations to fill out the giant chart. Be mindful that because the video is blurry, that one of the unknowns does have 2 possibilities, I guess we'll say, that you could argue that, like, oh, I think it's this one because X, and then you could also say, oh, I think it's this one because Y. There is one best answer, and if you look very carefully, you can see what it is. But if you guess the second, like, alternate close answer, I will give you credit for that. Note that that is only true for one of the 2 nitrates. The other one has a definite answer that you should be able to identify. And the sodium solution you should absolutely be able to identify too, based on your observations. Okay? So once you have done all of that and you filled out the table, the last bit is to go down to the analysis questions tab and identify what they are. Make sure you're typing in the entire name. Some names have things like parentheses 2 in them. Make sure you add that parentheses 2. That is part of the name. And then this last question, explain your thought process that guided you to determine the identity of the unknowns. When you are going through the process of, oh, this is how I got to the answer, tell me what you thought, and then support that using data. So if you say, oh, I mixed unknown number 1 with unknown number 3, and it turned this color, and that reminded me of the observations where I mixed A and X together. They looked very similar. So I thought that might be possible. And then, da 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 da. Okay, so that's what I'm looking for. This question is worth 3 points. All the other questions I think are just worth 1, aside from filling in the table, which is worth its own thing. And that generally means I want you to go into more detail. Don't just say, oh, I matched stuff. That's too vague. You'll get 1 out of 3. Why is 2 or 3 part of the name? We're going to talk about that in unit, I want to say 9 or 10. So we'll get to that. It has to do with the charge on the ion that's present. So like iron 2 would have a charge of +2, and iron 3 would have a charge of +3. What that means in more detail, we're going to get to later. All right, that's all I have about the lab. So again, download the documentation, make a copy of the worksheet, fill in the worksheet, save a copy for yourself or download as a Microsoft Excel document, and then upload that into Canvas to the Assignments tab, which will be available later tonight. If you have any other questions, let me know, and I'll be more than happy to answer them. So the next thing that we're going to do is, because the lab is, that's the lab discussion. That's all I have prepared for the lab discussion. I'm going to go to the break screen. Oh, our lab's graded on correctness or completion. They are graded on correctness. So if you answer every question wrong, you get 0. Typing in something, it does not award you credit. I do want the correct answer. Oh, the other thing I should say about labs is that while I encourage you to work together, for example, if you want to use the Discord channel to ask questions about, hey, I didn't know what color to describe this as, totally allowed. You're able to do that. You can use the Discord channel for anything. What you are not allowed to do, and I have had students get kicked out of the class for this after I forwarded their labs to the dean. Very, very crucial. Do not submit the same exact lab as somebody else with your name on it. I do check the labs, and I do compare them against other students, and if I find that your answers are word for word verbatim identical, you get a 0, and I file a petition to have you removed from the class. I basically try to expel you. That is academic plagiarism. Do not do that. Working together is okay, but you have to answer the questions in your own words. For example, if I asked you to describe a picture, no 2 students in this picture would write the exact same 3 sentences to describe it. And yet, magically, every time I give out these labs, I get labs that come in and have the exact same descriptions. So do not plagiarize each other, okay? You can work together, but you may not copy and paste each other's answers or share the same document. You must use your own document, okay? Be careful. If you go against those rules, you do so at your own peril, and you may be expelled from the class. Is the lab due next week? It is due 1 week from today, which would be a Wednesday. Yeah. So week 3, Wednesday, lab number 1 will be due, and then you get 1 extra day as the closing deadline for that. So do it by Wednesday, DO, do it. And then Thursday is the last day to submit it before the assignment closes. All right, I'm going to put the title card up. Or not title card, but the break timer up. I need to get the timer out real quick. It should pop up. There it is. And during the 10-minute break, please fill in the chat with any questions. I saw that there was one worksheet question. We'll go over that after the break. But while this is going on, I'm going to go and release the assignment so that that page is available. I know a bunch of people have already done the assignment because I've been getting questions about it all week. And that's totally fine. You just upload it. But if you want to go back and like revisit it or review it, or maybe something is done in a way different than what I prescribed today, you have time to do that. Okay. So I'm going to start the timer. I'm going to mute myself. We're going to put the music back on. More Persona 4. We'll see you in a little bit. Hi, everybody. So, again, the purpose of this next section... Oh, I gotta wind the music down here. The creepy end of Persona 4 music. Oh, Persona 4 is so good. But what's even better is Outer Wilds. So the purpose of this section is... Really, I just kind of talk with you guys, I guess. If you have questions about anything in the course, or stuff that you've been working on and you want to get feedback on it, this is the time to do it. So there was one question that is on a worksheet that I'll go over. I gotta find it. So give me a sec to get that, and then I'll capture it on the screen. But to answer the other questions that came up, I actually don't know how long the DLC is for Outer Wilds because I played it a long time ago, but it was not a Steam version. So, and then I changed operating systems. So when I bought Outer Wilds again for Steam, because this game is so good that I didn't care that I was buying it a second time. Play Outer Wilds if you haven't. It is Space Shenanigans, the game, and it is so good. So I'm playing through it again, and I actually don't remember clearly what is in the original game. So I'm finding all these breadcrumbs of clues to follow. And I'm like, was this here before? I don't remember this. Did I jump on this thing? Is this where I piloted my ship? Was this a thing? And so I don't know anything about the expansion, to be honest. I have a friend who has said that he's spent 8 hours or so and thought that he might be halfway through the expansion. And then he also reported that he is now perma-stuck. Not perma-stuck, but he's like, he doesn't know what to do. And I look forward to get... That game consumed me for probably a solid week and a half. I would sit down, I would play for like 8 hours at a time, because it's a game that you just get lost in. And I had to solve the space shenanigans, and it took me a long time to figure it out, but I was so happy when I got to the end of it. I was also super sad, because that is probably my third favorite game ever. And I've played quite a few games. Where is Worksheet 3? Here we go. My top 3 games from... So third place is Outer Wilds. Second place is Return of the Obra Dinn, if you've ever played that. Fantastic. It's a mystery, like, whodunit sort of game, where you are a tax inspector in the 1800s for the United Kingdom, and you investigate this boat that has come back, and everyone on it is dead, and you have to figure out why and how they died by using the magical pocket watch. And it sounds really bizarre, but it is fantastic. And then my favorite game ever is Super Metroid. So, like, nothing will ever top that, because that was just such a formative experience. So the taxes in the game are... It's the gist of the game is that you are figuring out what happened to the 60 people aboard the ship, so that you can pay them whatever wages were owed to the deceased, or make claims against them for doing any sailor who mutinied, for example. Their estate would not be given to any claimant; it would be taxed to the government. So you have to find out what was the fate of all 60 people, because they all died. The ship came back; it was a ghost ship. Okay, so now let's actually do some chemistry here. So 1p in the... Oh, okay, I see. Yeah, we can definitely do that. That's a common question that people have. So let me find PDF here. I think that's what I want. Yeah, that's right, but it's just too small. Oh, that's actually what I want. Okay. Okay, so the question is, convert these units to the requested units. And I'm just struggling trying to zoom in with Photoshop here. Now, we haven't really talked about how to do multiple unit conversions yet. However, you do them in the exact same process that you would do single unit conversions. You just do a bunch of them at the same time. Let me get the keyboard out of here. And uh-oh. Okay, good. I thought I lost the stylus. If I lose the stylus for good, I have to order another one off Amazon. That's never fun. Okay. I think this works now, so let's see here. Test 1, 2, 3, 4, 5. Look at that. No lag. Apparently the issue was, Professor West, you got to restart your damn computer more often. What am I balancing on here? Oh, yeah, that's not going to help. Okay. That's fine for now. Okay. I can't read this because it's so tiny on the screen, so I got to move this over here. So I can't see the chat for a second. So I want to turn 1,800 kilogram meters per second squared to pounds miles per minute squared. Okay. So the first thing we want to do is I want to set up my units so that I can do dimensional analysis with them, which means that anything that shows up on the bottom of a fraction, so anything in the denominator, there we go. We're going to actually put it in the denominator, so that when I do my multiplication to cancel units out, I can cancel it out in the appropriate spot. So never write a denominator on top of one of these fraction bars when doing dimensional analysis, because it just confuses you. Anything that goes on the denominator should be on the bottom of the fraction. All right, and then what we need to do is we need to make these units match these units. So in other words, I have kilograms, but I don't want kilograms. I got to turn those into pounds, yeah? I have meters, but I don't want meters. I want miles instead. And I have seconds, but I don't want those. I want minutes. So if I do 3 conversions, I could convert each unit to the other unit that I want. So let's start with the kilograms to pounds one. So we'll do this one first. So just like we said yesterday, if I don't want a unit, I'm going to put it on the other side of the division bar so that they cancel, right? So if I were to do this and then look up the numbers for pounds to kilograms, and I think it's like this, something like that. Now I would have pounds per meter per second squared. But that's not what my answer wants. I want pounds per mile per minute squared. So I got to do all the rest of the units too, right? So we just multiply those all together because multiplication can be done in any order. You do one thing at a time or them all at once. So I'm going to do the next one. I'm going to cancel out meters because I don't want it. So I'll put meters on the bottom. And we'll put the thing that we do want on the top. And then I'll just go look up how many miles or how many meters are in a mile on Google. So we'll do that. So mile, 1 mile to 2 meters. So 1,609. So 1 mile, 1,609.34. Let me put this. Oops, I thinks I'm right-clicking because I'm pushing it too hard or for too long or something. Okay, so now I got the pounds and the miles part. Now I got to get the seconds thing out of here for minutes. Now, with the seconds part, we have an issue. The issue is that most of our units have been on the top here, but seconds is on the bottom. So if I do this, will these cancel? And the answer is, well, no, they won't, right? Because they're on the same side of the division bar. They would just multiply together. So I don't want to put the seconds there. I want to put them up here. And so now my seconds will cancel. But there's an issue in the fact that there is a squared here, right? Squared means that you have seconds times seconds. So one of these would cancel out with one of these. but there would still be a seconds that remains. So what I need to do is I need to square this. But we're going to show how to do that in a minute. But first of all, I want to do this dimensional analysis. I want to turn seconds into minutes, and there are 60 seconds in a minute. But what do you do with the squared part? Well, if I want to square my seconds here, I got to square everything, which means I need to square this whole thing. So now I need to get rid of this because it's in the way. And the way that we do it with exponents is that we just square everything. So the squared is going to go here, and it's going to apply to this number, and it's going to apply to this minute, and it's going to apply to this 1. So this new conversion factor actually looks like this. 60 squared, seconds squared, over 1 squared, minutes squared. Now 60 squared is 60 times itself, which would be 3,600. And 1 squared is 1. So I'm going to just go like this. As the result of that. And now that I've done that, this second squared will cancel with this second squared here. And that will leave pounds, miles per minute squared, which are the units that we want. So now when I go to my calculator and punch all this in, the units that will be left over will be pounds per mile per minute squared. And so I just have to type these numbers in that we've written out. So we got 1,800 times 2.205 times 60 squared divided by 1609.34. And I got to scroll over here, 8878.42 2221. There's a lot of numbers. We'll just ignore them for now because we're not going to get to keep that many sig figs anyway. Pound miles per minute squared. And then the last thing we do is we check for sig figs. This number is written as 2 sig figs. This is 4 sig figs. This is 6 sig figs. And this is exact. Remember how exact numbers work. They're exactly 60 minutes or seconds a minute. So there would be exactly 60 squared seconds squared in a minute squared. Whatever square time, the numbers work out. And then all these ones are exact too, so we're just going to ignore these. So the smallest of those was 2 sig... Oops, hold on. Smallest of those was 2 sig figs. My answer should only have 2 sig figs. Oh, not 8,800. It should be 8,900. And that's what your answer... Oh, wow, that was bad. You know what? We just won't put a box around it. We'll just do that. And that's what the answer should be. All right, any questions, let me know. I did notice that my computer seems to have dropped frames, so there was probably a chunk in there that I dropped 5 seconds worth of, it looks like 5 seconds worth of stuff. So if the video froze for like 5 seconds around 3:25-ish, I'm starting to pin down the problem, and I'm thinking it's not me. I'm thinking it's Comcast. So I apologize if there was like a hiccup in the middle of the stream there. I'm monitoring my connection speed to see if like my video is going to completely cut out and drop. Can you convert seconds squared to minutes not squared? You cannot do that because you need to have the same exponent, the same power on both of them. So you could do seconds to minutes, and you can do seconds squared to minutes squared, but you cannot do seconds squared to minutes because they're not equivalent units. That'd be like trying to convert a length into an area. So you can't convert meters to square kilometers, for instance, because they're different dimensions. Now, depending on your application, you could, if there was a relationship. So, like, if you had the formula for a circle, you can convert a one-dimensional unit into a two-dimensional area. But that uses a formula, not dimensional analysis. So, without a formula, we cannot do what you're describing. Because a formula is used for a specific application. In this example, to generate the area of a circle from its radius. And in fact, to do that, you square the radius. All right. If you have other questions, let me know. We're going to do more examples of the problem that I just did on the screen on Monday when we finish up Unit 3. We might go into Tuesday a little bit to finish up Unit 3. Unit 3 is a big unit, and then we're going to do all these little teeny tiny units, one after the other, and we're going to get we're going to go very fast. It's going to feel like. Like, we spend one day on both Units 4 and 5, because they're very simple. And I think Unit 6 is 1 day, and Unit 7 might be 1.5 days or something. So, we're already 20% of the way done with this class, believe it or not. That's so weird to think about when you haven't done anything, it feels like, probably. But believe it or not, you've been doing a lot of work. This is not grunt work. This is actually, like, very important calculations and conversions that you were doing. Can we do 57 miles an hour to meters per second? Sure. So let me scroll this up. Now I don't know where I'm drawing it, so hold on. So I want to do something like that. There we go. Okay. So let's see here. So 57 miles per hour to meters per second. So first, again, we're going to take our denominator part and put it as an actual denominator. So there you go. And then I want to turn this into meters per second. So my miles needs to become meters, and my hours needs to become seconds. So let's do the miles part first, because that's easy, because we have that conversion from before. So I'll set up my units so that the units cancel. And then we'll fill in the numbers. So there were 1,609 I don't remember how many. 34 meters per mile. And then we need to turn hours into seconds. Well, I don't want to keep calculating how many seconds there are in an hour every time I do this, because that's just another thing I'd have to memorize, right? But what I do know, I know how many minutes there are in an hour, and I know how many seconds there are in a minute. So if I do this... Oops, hold on. That's the wrong color. If I turn hours into minutes, and in an hour there are 60 minutes, and then I say, okay, minutes and seconds, and there are 60 seconds in a minute, that works too, right? Because this thing right here is just how many seconds are there in an hour? Well, there's 60 times 60, right? But I don't want to have to do the mental math of 60 times 60 equals 3,600 every time. So I just write out things that I know. So if you have to take extra steps to do your dimensional analysis, that's fine. We don't always have to go in one step. In fact, the more common approach here is to just go miles to kilometers to meters, where you say, oh, there's 1.609 kilometers per mile, and there are 10 to the 3 meters per kilometer. Well, 1.609 times 1,000 is this number that I've been writing down, right? So if you want to break these into simpler, more elementary steps, absolutely, go for it. I'm just getting some of the numbers off of Google. Anyway, what are the units that are left over? Anything that we didn't cancel out? Oh, I lost my purple. Hold on. There we go. Any of the units that remain are the units that we will have for our answer. So when I do this calculation and I type it on the calculator, it will be in meters per second. And the number that I get is 57 times 1609.34 divided by parentheses 60 times 60. And I got this as my answer. And then why only 2 sig figs? Because this number has 2 sig figs. This is 6. And then these are exact. There you go. All right. Any other questions? Let me know. I'm going to hit mute on my mic. I'm going to put the music back on, but I'll leave it on this screen. And I'll let the music play for like 3 minutes or so. And if there aren't any more questions, we'll call it a day. I'm going to just go grab more water, pet the cat. So I'll be back, but let me know in the chat if you have any more questions over here. And I'll see you in a bit.
Can't get my mind out of those memories. Now time to tell them, don't take my dream. Still music keeps on tuning me from the worlds that haunt my soul, removing that from my mind. No
There we go. Sorry about that. I had to use the restroom too. All right, so the next question that was on there is 300 inches squared to centimeters squared. So let me clear this. There we go. Oh, you know what? If we're not working from the PDF, I can just do that. I have more space to work with. So, oh, wrong color. Hold on. 300 inches squared to cubic or square centimeters. All right, we're going to do an example like this, very similar on Monday. But whenever you have a squared unit, remember that inches squared is the same as inches times inches, right? And if you were to multiply that by something with inches on the bottom, it wouldn't cancel out all the way, right? So we would need to square the whole thing in order to cancel out both. So the way that you do that is you write a one-dimensional conversion that is correct. So, for instance, in 1 inch, there are 2.540 centimeters. And that's just a number that I know off the top of my head. But now to get this inches to cancel out with this inches squared, I have to square the whole thing. So that means that this squared term would go to 2.540 squared, to centimeters squared, to 1 squared, and to inches squared. Which side of the division does the unit go? Yeah, you're always, when you're doing these cancellations, you always put them so that they are diagonally across from the division bar. Because remember how multiplication works. If I have something like this, and I multiply by something, I don't know, say like that. That's the same as me just doing this, right? And so these would go away, and these would go away, and whatever is left over would remain. So we're always setting up our units when we multiply such that things that we don't want to be in there anymore, that we will write the unit to cancel with on the opposite side of the division bar. Number 4, sure. Let's finish this one real quick. So my units that are left over are going to be in centimeters squared, and I would have 300 times 2.540 squared. So when I put that in the calculator, I get 1,935.48. Now this number only has 1 sig fig. So my answer will only have 1 sig fig. So I would report 2,000 centimeters squared. Four. I gotta find 4. Oops, I can't see what I'm scrolling here if I do that. There we go, I can read that now. Sorry, what you see is much bigger than what I see. I can see what you see. I have a screen that shows that. I wonder if I can capture that. I wonder if you could see what I see. Let's see if I can do that. Well, I can't actually do that. That's strange. I cannot capture OBS on its own. That'd be kind of neat, but I'm gonna have to display capture that, and if I do that, then I will capture like everything, and it will just be a mess. So, okay, so But anyway, it's big enough that I can read it now. So a truck driver drives from Portland to Seattle. He covers a distance of 2.803 times 10 to the 8. Is that 10 to the 8? Maybe I can't read it. 10 to the 8 millimeters. That's right. According to the timesheet, it took the driver 7,925 seconds to cover this distance. If the speed limit between Portland and Seattle is 70 miles an hour, was the driver speeding? So, first of all, let's try and answer that question. How would we know if the driver was speeding? Well, his speed during the trip would be greater than 70 miles an hour, right? If the average speed was greater than 70, he must have been speeding at least halfway, right? Now, it's possible that he drove 10 miles an hour for most of it and then drove 100 miles an hour for all of it, and his average speed was still like 12 or something silly. But we're going to ignore those sorts of cases. We're just going to try and figure out, based on this, is it definitive that the driver was speeding or is it inconclusive? Now, we would have to get a number that was larger than 70 miles an hour, right? So we're going to look at a result and compare it to this. Now, do you know what the driver's speed actually was? Well, sort of. We know that he went this far. He drove 2.803 times 10 to the 8 millimeters. Who measures their distance in millimeters? Chemistry teachers do, to give you obnoxious problems. And then how long did it take him to go that distance? Took him that many seconds. Well, what do you think we should do? In order to compare to this speed, we would have to match these units, yeah? So I need to get rid of these millimeters. These millimeters are doing nobody any good. We'll turn them into meters, which will turn into miles, because we've been doing that all day. And then seconds is easy to turn into minutes, which we can turn into hours. So let's do that. So I don't want these millimeters, so I'm going to cancel them out down here. I'm going to turn that into meters, because I don't know the conversion between millimeters and miles, but I do know millimeters and meters. A millimeter is 10 to the minus 3 meters. And then we'll do meters to miles, again canceling these out, and then we'll do the numbers. A mile is 1,609.34 meters. That's just the number we've been using all along. Okay, so we got the miles part done. Now I gotta turn the seconds into hours here. So we'll turn seconds by... We don't want it on the bottom, so we gotta put it up here to cancel it. And then we'll turn that into minutes. We don't really want minutes. We're just using minutes to get to hours, though. And I forgot to fill in the numbers, but that's okay. You can always go back and fill them in later. In fact, what I prefer to do is I like to do all the units first and then fill in the numbers, but I try something different every now and then to see if that helps you guys. And there you go. So now I have my units in miles per hour. So when you punch that in the calculator, you should find this guy's velocity in miles per hour. And so go ahead and type that in your calculator, just so you can compare what you get to what I get, which is... So I got that with, let's see here. So here's 4 sig figs. This is 4 sig figs. These are exact. This is 6 sig figs. And these are all exact here. And the ones we can ignore. So my answer should have 4 sig figs. So his average speed was greater than the speed limit. So was he speeding? Oh, for sure. Absolutely. We know that for certain. I mean, we could just use common sense. I have driven the drive from Portland to or Seattle to Portland, and it is so like mind-numbingly boring from like Seattle to Olympia. I fall asleep every time I drive that distance. No problem. So if you're adding those two numbers together, 650,000 to 3,000, when you do your rounding, remember you're working from right to left when you're doing addition. So I would say, do I use this position to do my math? Well, no, these zeros are placeholders. I'm going to just draw X's through all the placeholders here. So this is the first position that you would hit where you have a known value or a sig fig in each position. So when I do the addition as normal, I would round to this spot. Or you would round to this spot, because that's the correct way to do it. And so you'd report your answer as 650,000, which would be a 10,000ths place. No problem. You got it. Happy to help. Yeah, let me know if you need anything else. I'm going to do last call for questions because we only have about 30 minutes left. So I'll give you 2 or 3 minutes to get some questions up. And if you don't have anything, we'll just call it a day. So let me know. So when you are doing these problems by yourself, this is what I recommend that you do. A lot of students ask me, wow, you do these problems so quickly and you can even do them in your head. Like, how do you do that? And the answer is I do what I'm doing on the screen every single time. To the point where I can just, if I was given any of these problems on that worksheet, I could do it in seconds because I have this process down to a T. I write out the units every single time. And if you ask any other instructor, they'll say, oh, it's because I write out the units every single time. So It seems like a lot of work, but once you've done this sort of unit cancellation uh, enough, this becomes a real trivial process, and it takes you seconds. So I can't say that I expect this level, because obviously you're doing this at home, and I'm not going to evaluate or look at your work, but I would ask you to attempt to do this level of work, because it will ultimately help you understand what's going on. So setting up all of your units and then canceling them out like this is by far the best uh, recommendation that I can make. Do not cross multiply or do things like, if 1 minute equals 60 seconds, then 12 minutes equals question mark seconds. Don't do that. Don't ever do cross multiplication or stuff like that. Do dimensional analysis like this. Well, if you round something, then it can't be exact, right? But the numbers that you've written both have 1 sig fig. So if you wrote 4 versus 4 dot, these both have 1 sig fig. So the dot is handy for situations where it's like this. These aren't the same thing. So this is 1 sig fig, but this one is 3. So if you rounded 3.5 to 4, you could enter either 4 or 4 dot. They mean the same thing. The dot does not imply exactness at all. In fact, you have to specify that a number is exact, because all numbers are assumed to be inexact unless stated otherwise. On any worksheets or quizzes or stuff, I will state in the problem description that an underlined number is an exact number. And if you don't see any underlined numbers, they're all inexact. Assume that numbers are inexact. Sorry, I'm opening my seltzer here. If we were on campus, I would bring cans of seltzer to work. Like, we have a refrigerator very close to the office that we have access to, and I would just fill it with seltzer. I would drink like 6 cans a day because it's just water basically with like a drop of raspberry in it. This one's original, but the other flavors I drink raspberry lime, cranberry lime, and lime. Can you spot the pattern? I might like lime. In fact, if you don't like water, try adding lime juice to it. Makes it a little bit bitter or sour, and that might be something that you like. Stay hydrated, basically. All right, anything else? Let me know. Last call. All right. That was pretty good. Thanks for using the Q&A. I know that a lot of the time, like, it's weird to come to these sessions and just kind of sit around hoping that somebody will ask something. In the past, as the quarter goes on, what tends to happen is that the Q&As don't really get much attention. But if you have any questions that you would like me to answer, remember that the Q&A is there. I will also happily answer questions on Discord. If you want to post them publicly, you could just punch them into the chat. If you're not using the Discord, by the way, I would recommend it. Lots of students are using it. It's going great so far. And fill out questions. I will answer them there. If you'd rather ask me in private because you're shy or something like that, I get it. I'm shy. I was a shy kid too. I'm still kind of shy, believe it or not. Like, it takes years to get over that sort of thing. So whatever you need to do is for me to be able to answer your question, like, let me know. Reach out to me. More than happy to do it. But for now, thanks for watching. That's it for this week. Make sure that you get quiz number 1 in by Monday, and work on that lab worksheet. It is due Wednesday. Have a great weekend, and we'll see you next week.